This real NASA intern gave me genius advice for my UAV startup, so let's go ahead and test his theories in FlyOut and see what we can learn from the advanced aerospace sector of NASA, also involved in the X-59, a supersonic jet developed to reduce sonic booms with insanely complex aerodynamics. And then I will ask GPT-4 how he would have done it, and we can see how well AI matches up to an aerospace engineering student. We are trying to develop an affordable UAV drone swarm capable of lifting 5 kilos per drone to deliver packages in dangerous areas like Ukraine's frontline or delivering food in the Gaza area. I am only 19, but I am documenting how I am achieving my dreams and how you can too. This is Naevius. If you're new to this channel and you haven't watched all the previous videos, I'm basically at week 3 right now of developing my own UAV swarm company, like I just said. But here's a quick recap from what I already did. I received help from 2 people, one of which tested out the airfoil that I picked before that. I made this concept for a more efficient and powerful motor setup using the VTOL motors in the forward thrust as well as reducing the aerodynamic drag, to which I have a better solution for in the new design later in this video though. And I made this tandem airplane in the previous video that we're going to dive into this video and try and improve this amazing plane. Currently we are at 8 people or 9 people helping me out that are currently in the Discord server, so thank you all for that. I will tell you all about what they helped with later on. So there's a lot going on, that's really nice. If you also want to help, you can email me with the email in the description, and then if it's all good, I'll send you an invite to the Discord. This morning, I got an email and that was so exciting. He is a NASA intern and that is so cool. So at NASA, he mostly does eVTOL designs for like real planes probably. And it's his second internship there at NASA, and he does like aerospace engineering on a university. So that's pretty cool. But he gave me a few recommendations that I thought were very genius. So I'm gonna go over them, and then after we got a bit of an idea down, I'm gonna hop into FlyOut and build a version in there to test out the aerodynamics and test out if it's very stable and if it's better. So let's start with the first thing he recommended. I'm going to quickly get rid of these motors and these wings so I can start with a clean plate.
Super Hands presents.
So this is roughly our current design, right? So the first thing he recommended was making the canards a bit longer than the main back wing and increasing the aspect ratio, so basically making it a bit thinner. I don't know yet how thin, so we can just test all of that out in FlyOut. So the total wing area of this should be smaller than this. So why would you do this? Well, this makes it so that the stalling is basically impossible. When there's not enough lift anymore because the plane is going too slow, these wings will stall first, and then the nose will go downwards, and then this back wing will be able to pick up speed again so it can just recover from the stall. I thought that was pretty genius. Now the other thing was that the canard should be located lower than the main wing. Now obviously the wing creates a wake, that's what you call it, that's what he called it. And it's basically the thing that we saw in the wind tunnel, so like the wind comes here, it goes over the airfoil that's currently non-existent, and then a flow of air will go downwards, which probably makes the plane go up, as far as my understanding goes. And it will also do some stuff with the backwards stuff, it'll also go backwards. And now, if the main wing is lower than the canard, then that wake that he was talking about has a chance of hitting the main wing here in the back, and this could apparently have a negative impact on the efficiency or the lift, if I understood him correctly, because he didn't necessarily say if this was negative or positive. I think it's negative. These are all things that are currently theoretical. We need to test out if this would be a problem or not. But in my opinion, it does look pretty cool, so he said that with this configuration, the plane will be aerodynamically stable if I put the center of mass slightly in front of the center of lift. So that'll mean it's gonna be stable and it will have a slight tendency to go downwards with the nose. But as he rightfully said, that's a lot better than a tendency to go upwards. If the plane goes upwards too much, then eventually the wings will not have enough air to actually produce lift and give you control. So the control surfaces would stop working, and then you kind of have nothing that you can do about falling down and crashing and burning alive. So then with that configuration, he said that the pitch control surfaces have to be on the canard, and then the roll should be on the main wing. So I think for now this configuration is pretty clear. Now let's go and fly out and test all of this out. Before we go ahead and do that, I want to tell you real quick, because I'm editing right now and I'm just seeing what I came from and where I got to this week. Maybe it's still a bit frustrating to watch me say stupid things, and what I'm doing here was very unscientific, and we're gonna be taking a slightly more scientific route later on in this video. It's going to get a lot better, okay? So yeah, my bad. Well, not really my bad. I cannot really do that much about it, but okay. Okay, let's go ahead and load the absolutely perfect aircraft. Oh, now I gotta get used to the FlyOut controls again. Oh my god. So let's go ahead and make a new save file so we don't lose the perfect plane. Actually, I'm just going to take the one with the landing gear instead. Perfect. Okay, so let's go ahead and make this wing slightly smaller. Something like that, I think. And then we can make this wing smaller as well. It's not what I meant. Oh my god, now I messed it up. I forgot that I don't have Ctrl Z. Oh my god. Oh, and the battery is connected to the wing. Oh my. Alright, we're gonna have to do a lot again. Okay. No, what am I doing? What did I just do? Oh my god, I'm already frustrated. So now, bring this nice and low. Oh, I don't know what happened with this here. That's really weird. What is this, dude? Now let's make it a bit thinner. Would that be thin enough? I'll try it out. And then we can go ahead and make this longer than the rear wing. Okay, so we currently have this. Now let's also make the rear wing a bit higher, like that. All right, something like that, I guess. Now, my fuselage is not really built for this, but I hope it doesn't impact it too much, so I'll just try it like that. Now let's set up the control surfaces real quick. This is definitely way too big. I don't know what the right place is for control surfaces. So let's add the pitch controls. Oh no, wait. First we need to make this a bit smaller. I think I'll just do it in the middle, like right about here. Add some pitch. Perfect. And then we can use this for the roll. Okay, now for the center of gravity and the center of mass, this is not what he recommended. And that's kind of because I don't have a battery anymore. So let's go ahead and add a battery real quick. Battery about there. Okay, it's already getting better. Let's make it even better. Now it is pretty hard to get the weight in the front, so I'll just make the lift go to the back a bit. I don't really know how to make this situation better. I cannot imagine that this will make it better. You know what, I'll just put a bit of fuel in the wings, I guess. I hope it'll take off because that'll make it heavier, but we do need it that way. Okay, so that didn't even do that much. We added 100 kilos and it didn't do that much. Alright, okay, so if we kind of bring it more to the back, but not too much, and then we can kind of the battery up a bit. I don't know how slightly it should be in front of the center of lift. By the way, he added me on Discord a bit later on, and he sent me a link to this website. It's about like Kerbal Space Program, and it's about how you balance a plane. But it's still not very specific, but it does say center of lift ahead of the center of mass, flips or turns uncontrollably, you don't want that. Center of lift inside of the center of mass, excessively maneuverable, needs constant course direction, which some other people in the Discord told me fighter jets have. Center of lift closely behind the center of mass is more maneuverable. Center of lift further behind the center of mass is more stable. And center of lift very far behind the center of mass is very hard to correct course, likely to flip up or nosedive. So it's really finding the right balance is really a tough part. Later on, a guy contacted me that is pretty good at FlyOut, so he showed me a bit like how you have a good center of lift and stuff, so I have a way better idea of this now, but you'll see all of that later. I don't think this is exactly how it was meant to be. Well, I'm just gonna try it out and we'll just see what happens. The plane sounds were too much, so I'm just going to do it in a voiceover. It didn't fly. It's definitely too heavy though. I forgot to change the airfoil and it was very unstable. I'm gonna fix this airfoil first of all, and then it's definitely an issue with the weight. definitely. By the way, take my confidence with a grain of salt. If I say definitely, it's probably not the case, but you never know. This looks a bit better. No, I don't think it's gonna fly still, but we'll see. Okay, we're at 120... Not knots. Did I say knots? Well, I found this out very late, but it says kph. I think that's knots per hour. Sorry if I'm still gonna say it later on in this footage. I didn't know just yet. I know it now. You don't have to comment it, but you can comment though. That's always nice, you know. Let's try and take off. Oh god, it's very unstable. Like, obviously this has to do with the weight in the wings. Yeah, let me just fix that real quick. That's not gonna work. Alright, bye-bye fuel tank. Oh, that's what I was talking about. Look, the center of gravity is glitched in this game. You might like align it and then it'll still be different and wrong than what you did it as. I'm not making a lot of sense, but yeah, apparently it was not that hard to achieve this. Okay, this is more like what he said, I think. But we're gonna try it out and then we can just do some refining. Okay, I'm quite confident that this will fly for some reason. No wonder it didn't fly with that center of gravity. I think it's already trying to take off now. 130, let's try to take off now. Okay, we're not off the ground just yet. Okay, let's try it again. No? Nah, we're not there yet. So I assume that this is too drastic, so let's go ahead and do some refining, like I said I would do. It's really annoying that the battery sticks out, but I don't know a better like counterweight or balance. Okay, I don't care that it sticks out. I don't think it'll do that much, but I massively made this difference smaller, but I think this is still a big difference, but it's definitely way more likely to take off, I think. For some reason, it's not wiggling that much. Now, obviously, having the center of mass in front of the center of lift is going to be making it harder to take off, but during flight it's going to be better. So let's just try and take off from the air and see how that goes. We can easily see if it's more stable, and then later on I'll try and make it able to take off itself. Okay, here we go. So try and go upwards. It's automatically going upwards. I do have good control though. My nose is going upwards. I think the center of gravity is glitching, or it's my thrust. Let me see. Let's test out what happens when we stall though. I'm just not gonna do anything. And then it goes like this. Down. So it was right on that. That's amazing, dude. That's really cool. But it does keep going upwards. I don't get that. It's a lot more stable, and it's currently capable of climbing way better. I feel like it's a bit faster than the other model, but I'm not entirely sure. So, I went ahead and tried a bunch of different wing configurations for about 1 hour, and then I decided to just take a video of how it flies and send it to the NASA guy on Discord. I told him what it was at right now. I asked him how much smaller he thinks the cord should be at the front, and I told him that it wasn't that stable still, and I wasn't able to fly very slowly like I was able to before. So then he told me there's this rule of thumb for your horizontal till area that it should be about 25% of your main wing, and then he believed that that also works well for canards. So what is aspect ratio? Well, he had a little formula right there, but I'm here to visualize it for you guys. So imagine, this is a plane, the wingspan is 3 meters. You start off by taking the wingspan and dividing it by itself, so 3 times 3 in this situation, which is 9. Then you need to go ahead and calculate the wing area in total. So you take the chord, let's say the chord is 20 centimeters, 300 centimeter wingspan times 20 centimeter chord is 600 squared centimeters. Then you basically take these two numbers and divide them by each other, and then you get a 1.5 aspect ratio. Now I must say I'm still very confused with this whole formula, because what if you're American and you have inches and foot? Wouldn't you get a different answer? I don't know, we can figure that out later, otherwise this video will be too long. Because like last week, I'm currently stranded on a Sunday past 5 editing this video, and I'm not even halfway. And because of my time issues, I asked the NASA guy, can't you just make a few clones of me? I mean, you're an intern at NASA. You should be able to do that. So I was like, yeah, I can. Here's 4 more of you. See, I told you guys, he is amazing. So let's have a look at what all of my clones are doing right now. Starting with the first clone. So I was spending about an hour of trying his new advice out. I wasn't really succeeding though. But then the NASA guy sent me this, and in FlyOut it was hard to see some of the metrics and numbers, so he recommended me this open VSP software made by NASA to make parameterized, how do you say this? To make parameterized vehicle conceptual design. So that was quite interesting to me, so I looked it up real quick and went to download it. It was fairly straightforward. It had a bit of an old feeling. The UI wasn't the most user-friendly looking and it looked a bit old, but it wasn't bad. It was actually quite easy to learn. But on this footage right here, I didn't know anything. I was just getting myself familiar with all these settings and all the movement. The movement is the worst part of the software, but I mean, you kind of get used to it. It also didn't have Ctrl-Z though. The cool part is that this software doesn't use any metrics. So it's not meters, feet, inches, whatever. You just decide yourself what metrics that you use. And that's a good idea to stop our little metric system war here. Oh, and don't ask me how I got to this point. I swear it was an accident. I don't know, yeah. So I did find the wing features very useful, and especially these settings here. It's really interesting. You just select which 3 requirements you have for the wings. So then you can just, for example, slide the span around and it'll keep all of the selected numbers the same, and all of the other sliders like aspect ratio and area and stuff like that will change. So that's really a time saver for like not having to do math. So while this clone is working on learning this program without tutorials, let's go ahead and switch to my other clone who is working on clearing his mind. If you aren't interested in the realistic part of business, then you should skip this part and go to this time right here on the screen instead. But I want to make a realistic series, so I want to show you the hiccups I have that don't have to do with engineering as well, and how I solve them. So basically, I'm only 19. I've never owned a company and I've never had people do something for me. So basically, we're back at Monday right now. And at this point, the NASA guy reached out, and also another guy, a software engineer. And that's amazing. I'm not going to say no to that because that's straight up amazing. But on the other hand, if people are actually looking to do something, then I need to like have something for them to do, because if I don't give them anything to do, then I mean, that's wasted opportunity right there. So I didn't want to do that, but I also didn't want to give them something to do that I didn't even need, or something that's stupid that I regret asking, and then I'm just wasting people's time. I don't want to do that. So that was very stressful. Once again, I had nobody that can tell me how to handle this or how to do this, so I was genuinely stressed. Now, as I said, this was Monday, and it was the day after editing on a Sunday for 11 hours. And I realized that working 7 days in a week for 2 weeks, it was going alright at this point, but it wasn't like I knew that it's not going to be possible to keep up work if you're doing it 7 days a week for more than 8 hours a day. That's not healthy. There's a reason everyone has weekends. So I had to do something about that. So I had a call with my uncle, who's a lot like me and has quite a stressful position at work, as well as my dad, to ask how he manages projects. He is a project manager, so he actually has a lot of useful information for me. That's really nice. Now the issue is that all of what I just told you is stressful, but along with that, I was never able to turn off my mind to not think about this. I have a busy mind, but even when I would be finished with working, I would still be thinking, and then, like for example that Sunday where I worked 11 hours, I couldn't sleep until 6. Living on such a small amount of sleep is just not it. So I do remember that when I had an internship at a company, it was also quite stressful, but at that job you just leave the workplace at 5, and then every bit of stress stays inside of that office. And I don't have that when I work at home, and it's really hard to create. So I decided that I have to take everything that's in my mind, take all of my ideas and put it on a very clear mind map, literally. Mostly to not have to think about everything myself and just having it stored away in a place where I don't forget it, but also to show other people what I'm doing and to make it clear what all the plans are, so we can take each block that I'm adding in here and we can work on that. As you can see, it's already a lot of things, but genuinely I was very shocked with how big this mind map ended up becoming. It was a lot, and I don't think anyone's going to read all of it, and I don't blame you, but it was very nice for me to be able to put that away and to just have it all somewhere to look back on. I guess it also makes me and other people more confident in my project because they can now see a clear plan. I have a clear path to follow and to work towards, and it's really exciting. So, back to clone number 1. So, I was nearly done with my wing configuration in the NASA software. I felt really cool using NASA software. So, I took a quick screenshot of that and added it as a blueprint inside of FlyOut. So I can just trace the wings on top of it. So, let's have a look. Now, it was very hard to make this thing go upwards. It was near impossible. What clone number 1 didn't know yet, but what current me does know, is that the plane was probably too heavy. That's why I could not control the plane when I had the center of mass too much in the front. Like in this clip, I just couldn't go up even at 100% throttle. So I went back in the NASA program, made some changes, made the cord a bit thicker because I thought it had to do with the speed not being enough. And then I added that blueprint inside of FlyOut as well to try that out. It was a bit better, but I still couldn't get it to fly straight. It was always losing altitude, so that's pretty sad. So clone number 1 was really going to spend a few more hours trying a bunch of stuff without thinking about it. Back to the mind map. So if you're not interested, please skip a few seconds again. I'll just put a few timestamps in the description, okay? So I decided to make all of the blocks that we need to work on right now red. Those are the things that I need to work in the proof of concept, or the first version that I also want to be able to sell, but mostly as a proof of concept. So people know that I am capable of making the drone work. I have a version in real life. All that's required is funding. So I added a bunch of stuff like this in the Discord server and added a few channels. So everything's very clear, and people that join in can just read and see everything they need. So enough about planning. Basically, our current goal for this video is getting a concept, a very rough idea for the design ready so that the people that are helping me out can actually start doing stuff. The plan is to make a rough CAD drawing from the design that I have in mind, and then we can try that in realistic simulations, and we will also be able to compare the realistic simulations to FlyOut, so that'll be a fun thing to watch, I think. And then we just go from there. So right now I need to figure out a good aerodynamic drone design that we can base everything off of. So let's switch to clone number 3 real quick. He is a marketing genius apparently, and a visual design artist, aka the one and only Siep. Okay, enough ego stuff. So I was still a bit uncertain about the design I'm going for. I think at this point it was Wednesday, but my channel was really taken off pretty nicely, so thank you guys for that. And I finally thought of a name. Personally, I feel like a good name can make you feel very much more proud of your company or your whatever. So that Sunday night I was talking about, where I couldn't sleep until 6, that night is the night where the name of this company is born. You say it as Naevius, okay? Naevius. Why this name? Well, it is kind of stolen from the name of this bird, the Ramphadon Naevius, and I think that's just a very cool name. I believe there's no company with that name. Also, it's a hummingbird, so it's capable of flying still, just like our VTOL drone will be. This bird actually lives very high, about 500 meters high in Atlantic forests, and it even eats at like 50-meter height, which is apparently quite crazy for birds. Along with that, the Naevius is apparently the bird, and the Ramphadon is the genus of the bird. And the Naevius is the only bird in the Ramphidon genus, so it's a one of a kind, just like Naevius. Ah, so great. You see, I really thought about this. I also have a few product names, like the first drone will be called the Naevius Matrix. Well, why? Wait, let me get my notes here, because I wrote it all down. Okay, so the first product name, Naevius Matrix. In math, a matrix is an array of numbers or symbols, perfect for a swarm of drones. It also means it's something with something within it in geography and biology. I know that sounds confusing. Implying advanced technology or capabilities housed inside of the drone. That was my idea behind that. Then we have the Naevius Nexus. Nexus is a central or focal point that connects multiple elements together. Could be a name for an antenna drone that controls the entire drone swarm. Then I still don't have a very good name for a future long-range version of this drone. And then I have the Naevius Phantom, speaks for itself, good for a stealth drone for the future as well. So I thought that was pretty cool and I was very proud of that, so I really wanted to try out and make the design that I had right now inside of Blender, because now that I had the name for the drone and I had kind of a design for the drone, I could make a super cool concept video thing, and also because I want to make a proper channel banner and profile picture and really give this channel a nice premium feel. I really like that and it makes me very proud of what I do. So I had the super cool idea of a video where you see the drone flying around and turning into the VTOL setting mid-flight, going towards the camera, and then it turns on the lights and then it flies backwards, and then you see a whole swarm of drones that all spell out Naevius. I thought that was such a cool idea. So I spent around 3 hours, probably a bit more on that, but it was quite cool. It was quite a cool video, I'm not gonna lie. But you guys don't have to work 3 hours for something to see it, so here is the video. I'm sorry if it's a bit loud, that adds to the realism. So put your volume down a bit. Alright, enjoy. So in the meantime, this guy named Big Ham was kind enough to reach out to me. In my opinion, he's basically a FlyOut pro. He made a lot of really cool looking planes. And he was kind enough to hop on call with me and tell me a few things that I should change on my plane, because there are a few things that you just have to know about the game, and I didn't watch a whole lot of tutorials, so I didn't know all of these small details that can like make a plane fill inside of the game. And I'm even talking about the ones that don't even have to do with the aerodynamic aspect or the technical stuff, but like really small things. For example, I noticed that the control surfaces would like wiggle around when the plane was going very fast. Apparently this is because in the game a control surface only works if you have an engine. And the thought behind that is that it's a hydraulic system and that doesn't work without an engine, apparently. So he told me that you can just take a jet engine, make it unrealistically small, add a very small fuel tank in there, and then just turn on unlimited fuel when you start the game. So that solved that issue, and that actually helped my plane be a lot more stable. Now, along with that, he also told me about how I should set up my propellers. I did it very wrong. I completely missed the part where you can like set an angle of attack. Apparently my angle of attack was 0 on the propellers. So he told me how to do that exactly. He told me to use a different propeller type. So along with his changes and a bit of my own messing around, I was able to make the propellers put out about 10 times more thrust than previously with the same weight and everything. So that was a game changer, like a big game changer. So as you can see on this footage, the flight is quite stable here, so I was happy with that. And then I thought, now that I have very strong motors, let's try and make a quadcopter in FlyOut. Now, apparently this is very hard to do, but I wanted to make a VTOL plane and hopefully test it out in FlyOut. I'm probably not going to fully do that because that's a waste of time. FlyOut does not have like a gyroscope, I think, or an easy way to control a drone or keep it stable. That's why creating a drone or a quadcopter is extremely hard in FlyOut, according to what I heard. But I liked the challenge, so let's go ahead and give it a try. Before we can do that though, I kind of have to talk about what our motor configuration will be. because like I said, I thought of a different solution. I talked about it with the NASA guy and other people. Basically, I decided to go for a ducted fan configuration. Ducted fans can increase the thrust and efficiency, so that's pretty nice. And it's also quite easy to build it inside of the wings without wasting airflow too much. Basically, ducted fans stop the wake from the tips of the propellers from being there, basically, which means it's not like disrupted as much. That's the best I can do in terms of explanation. I'm sorry. You can look it up though. So to visualize how exactly I wanted to do this, I quickly made a setup in Blender, and also to show it to the NASA person and the people that are helping out to see if they agree, and they did agree, so here's the explanation. So I want to make a very low poly prototype to explain this to you guys and to the others. So let's imagine that this is the fuselage. Let's just make it this big. Make a quick wing. So currently our design is roughly like this, right? So how about we ditch the back motor entirely and just... So this is a ducted fan. It kind of looks like a jet engine. It's probably off and not proportionally correct. I think it has to be more like this in our case. I don't know. We'll see. Now we need it to be a VTOL. So at first I was like, we could just mount it on the wingtips, and then we can just take off, and then when it's time to fly, we can just rotate it like this. The issue is that the wing would have to be very strong, and it might be a bit hard to control because it's so far away from the place that you need to lift off. So me and Josh came with a different idea. Something along the lines of this. So this is better because it's closer to the base of the drone, so it'll be better to control. But there are a few improvements that we can go ahead and make right now. So this is currently how it would look in the horizontal flight. Now the nice thing is that you still have 4 motors, so you should still be able to fly way more efficiently. Now we can make this better because we need a system to turn the motors. So what if we just add the wing to the motor? So it'll go like this when it's in VTOL flight, and then the air doesn't have any drag when it tries to fly upwards. You don't have these huge wing surfaces that the air has to push against, but you can just have this aerodynamic wing like this. So I think that'll make it more efficient as well. So now each motor will have to accelerate wind, obviously. So currently I think if wind comes in this motor, it'll fly towards this motor, so then this motor would have to accelerate wind that is already accelerated. So I think it's better if we move these motors to a different place, probably more to the right, so that both motors can accelerate air on their own. But another benefit of this setup is that this motor will go towards this wing, and when this wind hits the airfoil, it can create a bit more lift. And if that works well, the way I think it in my head, that would mean that we need less wing surface, and that also means a more compact drone. So I personally think that this is a pretty good design. Just let me know if you think it's bad. So now that you understand how we're gonna do it, let's go ahead and try to start to build a drone. So I was going to keep the motor placements in mind. I was gonna use the placement that I just explained. I just took the body that we already made in the previous video, and I added the motors to it without very huge wings, because I just wanted the drone version to work first of all. Now, because I knew that in FlyOut you cannot really control the motor separately, or at least I don't know how to, I decided to try and do it by...
Although it looks a bit sketchy, it was by design very stable. At the heart of the train was a gyroscope that could correct the train's tilt before the passengers even noticed. But how did it actually work? The entire thing.
I decided to try and do it by turning the motors so that the thrust is kind of directed elsewhere, meaning that a specific engine has less force, less upwards force, so the other engines are stronger, so then it would tilt in the direction of the engine with less force. Just like a regular drone, but then mechanical. So, as if it's nothing, we're now 2 hours later, and I got this flying version. As you can see, it was unbalanced though, and that was the hardest part about this. I spent about 3 hours trying to balance this. I also had to figure out how you find the center of lift on a drone or a quadcopter, and that was actually quite easy. You just take the middle of it all. So Yeah, I already thought so, but I just wanted to make sure. So after a lot of balancing, I finally got it right. I gave it a quick paint job. I mean, I still couldn't fly it for more than 3 minutes, and I kept doing front flips. And I'm not gonna say if that was on purpose or not, but I did recover. That's the most important thing. So yeah, this was a nice little side quest that I wasted about 6 hours on. So then I kind of wanted to make a flying version of the plane we already had with these 4 motors to see if it could fly stably and like how efficient it was. So I did a few kind of educated different guesses on how I could configure the wings, but those kind of failed, so I abandoned that. And because before I add the motors to these wings, it needs to fly stable and stuff. And I still wasn't fully happy with what I got so far, so I did what any person would do. I asked ChatGPT to make me a drone, and that was actually very interesting. I will take you along in the process, and it's really surprising to me how somebody without any experience can just go to ChatGPT and get a functioning drone design or concept if you ask the right questions. And aerodynamics is a hard thing. I was very impressed. Okay, I'll stop talking. I'll show you now.
Okay, I want to make a plane with 4...
Yeah, I'm not gonna read all of that out. If you want the prompt, just pause right now and look at it and use it or something. So basically, I took all of ChatGPT's answers. I also asked him to clarify a few things that he didn't clarify. He told me exactly where to put the wings on the fuselage. He told me which fuselage to use. He told me the size of the wings. So I had everything to go into OpenVSP and try it out. Okay, so I had to ask for a few measurements again, but basically this is what it made. So this is a chord of 0.5 meters, this is a chord of 0.3 meters, the width of the fuselage is 0.4 meters, the span is 3 meters here and 1.2 meters here, and they're all located exactly where AI told me to do that. And I must say, I do not like how close we are getting to the original idea. Now, I was very impressed to see that all of the calculations that it gave, including his prediction on where the center of mass and the center of lift will be, were very accurate. And that was super surprising. I don't know where ChatGPT was able to get that from. I don't know if there's easy to know formulas. I don't know, but it was really impressive. So after a bunch of struggling and adding it into FlyOut, I was finally able to test it, and it looked like it would not fly. And the results were pretty surprising to me. If this is working, I'm gonna be amazed. It's not producing a lot of lift, it's currently basically a rocket. Right, yeah. Okay, I hope this video doesn't get demonetized. Not that I get any money, but you can make that happen by subscribing. Okay, well, I think I fixed it. Now let's go ahead and try it out. Okay, so let's see what AI is capable of. Okay, I'm trying to get some lift here. Okay, we're getting there. Okay, it's actually quite stable. Look how fast this turns. What the hell? I mean, it's probably because of the center of gravity being so close. And we're going pretty fast as well. Why is this actually so incredibly stable? It was actually amazing. This made me a lot less confident in my aerodynamic knowledge that I built up after 3 weeks. I am impressed every single time I use AI, I'm not even going to lie. This really shows that even the things you don't expect to fly will fly, and the things you expect to fly will not fly. But I'm currently flying the fastest I've ever flown, in the most stable way I've ever flown. And I'm not even using much throttle. So then I was ready to proceed with adding the 4 motors, like I said, so we can finally see if that's going to fly stable. Now I must say, it is slightly less efficient than this one prop version I made with AI, but I mean, it's 4 motors and I don't think FlyOut is too realistic with like the throttle efficiency thing that I showed last video. But it was still quite impressive running 4 motors at like 50% less efficiency, roughly. It was by far the nicest plane that I built in this game. It doesn't look good, but it flew very nicely in my opinion. I was able to control the angle of attack because I could just turn the motors. I wasn't able to make it a VTOL drone just yet. I don't know if I'm gonna do that, because like I said, it's a waste of time. I did manage to add a payload. Basically, I added its own weight as payload, and it flew just like normal. Basically, no noticeable efficiency decrease or anything like that. So then I quickly talked to the FlyOut Pro, and he gave me a few more small tips to make it fly even better, and then it was basically flying perfectly. So then I was ready to show the NASA guy everything I made this week, so I can ask him, do you think it's going to fly? Do you think we should waste time making this into a CAD file drawing and test it in realistic simulations, because that takes a lot of time? And he said yeah. He said he kind of expected a design like this and it was really what he had in mind, so that was very affirming. So yeah, next week I'm going to make all the realistic measurements, send it all to people that know how to do CAD drawings, and then we can start thinking about the motors and stuff. So please reach out to me if you know anything about EDFs or ducted fans, or if you think I should just use propellers or something else, please reach out, because those things are very complex to me and I would love to get some help to figure out the right motors and stuff, because next week I will not be able to work for 2 days because I need to go to a college boot camp thingy. Not looking forward to it, but so if you want to make it easier for me to still show some content, it would be amazing if someone takes the time to research this a little bit and figure out which exact motors I would need for a real prototype and to actually test stuff out. I have a 3D printer, so if you have any files that I need to print for an EDF, for example, that would be amazing too. I would love to test all of that. So thanks in advance. Thank you for watching. Bye bye.